And we are live.
Thank you, Pedro. Hello, everyone. I hope you're having a wonderful day, and thank you for being here, and thank you for taking your time to learn a little bit more about the wonderful world of data science. My name is Tiago Franco. I'm the CEO and founder of Imaginary Cloud. We've been on the market as a digital product development company for the last 12 years. We helped a lot of bright people launch wonderful digital products. We try to focus on launching products that are easy to use, because we believe that happy users equals to happy clients. This is our motto. We focus a lot on the user experience of the products, and also on the back end, how things work swift and fast. And that then brings us to a point, as a lot of companies start growing and having access to a lot of data, that then brings us to a point where a lot of our clients have products that need to be grown with the decisions made based on data, or any new features that require artificial intelligence to make the applications easier. And everyone always has, when they get to a stage, has a question on how can I integrate the data science discipline or artificial intelligence into my business. So this is the reason why we are here. We are here to share what we learned and our own experience doing that from the past years. I'm here with Pedro. Pedro will be doing the presentation and sharing his knowledge. Pedro is was the first data scientist to join Imaginary Cloud a few years ago, and has since then helped us grow this competence within the company. We now have a bigger team that we had in the past, and we are sharing a lot of the learnings with the team internally, so that we can deliver always a better and more efficiency on the projects with the data science in mind. And this is exactly what we would like to share with you based on our experience. We will be asking a few questions during the process on the chat, to know a little bit more about the pains that some of you might have. And I hope that by sharing that with us, we will then be able to address those topics towards the end of the presentation with the Q&A session. We'll try to cover as much as we can by the end of the presentation. On those Q&A, there might be some questions that will go unanswered just because we won't have enough time. But then afterwards, when we finish the presentation, you will have access to the video, and you will receive an email with our contacts. And then if you need to have some of those questions clarified, you'll be more than it will be very easy for you to reach us, and you'll be more than happy to talk afterwards. So without further ado, Pedro, thank you so much for helping with this presentation, and we're all ears.
All right. Thank you, Tiago, for the introduction. So before we start the webinar, as Tiago mentioned, we would like to know, or we would like you to answer on the chat a couple of questions, which are, so what would you like to achieve when you're trying to integrate data science into your business? So what is your objective with that? And also, if you already started, or if you're just starting, what are the main challenges and difficulties that you're facing? So please, if you can, try to answer those questions in the chat. And also, before we start the webinar, I would like to invite you to ask as many questions as you'd like on the questions tab, and we'll try to answer as many as we can after the webinar. So I'll start the webinar now, sharing my screen. I hope you can all see it. Tiago can confirm.
Yeah.
Okay, perfect.
Thank you.
So this webinar is going to be about all the secrets to integrating data science into your business. So integrating data science into an already existing business is really a very complex challenge. We've been working with different clients for the past few years, and we've been usually we find that companies have difficulties in the following areas. So one of the first difficulties is building a data science team. This is difficult for two main reasons. One of them is recruiting. So as you may know, recruiting software engineers in general is already a hard process. And recruiting data scientists also has even more complexities added on top. And also the second difficulty is knowing how to structure the team. And we'll take a look at those topics during the webinar. Another difficulty is setting up a proper machine learning operations flow, or even setting a machine learning ops at all. This is a key step to start building machine learning features into your product if you're building a software product. And so we are going to look at how we can do this during the webinar. Another difficulty is also setting up processes. So if your company is developing multiple data science projects, or if you're planning to develop multiple data science processes, or multiple data science projects, it's important to set up a process so that you can have a uniform planning and development of the projects across all of them. And so you can usually find ways to make those projects more efficient by setting up a process. And finally, we are going to take a look at how you can scale up your team and your data science department. And here we're going to cover how to properly structure this department in terms of which roles are important and how they communicate with each other. So as you may know, data science is a very broad field. It sits at the intersection of computer science, math and statistics, and also domain knowledge or business knowledge. And so it incorporates aspects from all of these domains. And as such, usually data scientists tend to focus more on one aspect or another. And it's difficult to find people that can cover the whole spectrum. And so that's why we are starting to see specializations inside the data science domain. And we're going to see how this can happen. So at its core, data science is about making the connection between business problems and mathematical algorithms to solve those problems. The business side, you have your business problems, needs, goals, objectives, which are usually expressed in terms of requirements that can be user requirements, functional requirements, or non-functional requirements. And the job of the data scientist is to take these requirements and figure out which machine learning algorithms can be used to solve them. And so it's important for data scientists to be familiar with all these different algorithms and also their mathematical backgrounds. This is data science at its core, but to integrate data science into a business, you need to do much more than this. So data science is connected to all the different subdomains of engineering. But if you already have a product engineering team, for example, with backend engineers and DevOps engineers, and also front-end engineers. If you try to start a data science branch just with a data science core, or just with a data scientist, you'll find that there are missing bridges that connect your data scientist to the rest of your engineering team. And so, as we'll see later, hiring or getting a data scientist to your team as the first team member might not be ideal, because he or she will be completely separated, and it's going to be difficult for them to communicate and to work with the rest of your engineering team. And we'll see how this can be solved and what is the best approach to start a data science branch on your business. So let's say your company is growing and you have a great product and you want to open up a new data science branch because you want to add some nifty machine learning features to your product. Because if you mention machine learning or AI to investors, the value of your company will probably triple. Your first thought is probably that you're going to add a data scientist to your team. And we are here to argue that that's not quite the best idea. And we already gave a hint as to why that is. But the key here is you shouldn't get any data scientists, because many software engineering concepts aren't part of the typical data science workflow. Things like code versioning and properly structuring your code, unit testing, strong typing, and web applications and APIs in general. Some data scientists will be familiar with those, especially if they come from a computer engineering background. But these days, many data scientists come from a mathematics or statistics background, or even a business background or biology background. So these concepts aren't really part of their everyday life until later in their career. And so this means that if you get a data scientist into your team, you will have to sidetrack some of your current developers to support these data scientists. And as you may imagine, this isn't ideal. So one of the first secrets that we have to share is, if you're starting a data science branch in your business, you should get a software engineer with data science skills. And this is what we call usually a machine learning engineer. And so this machine learning engineer should have experience with product-oriented machine learning. And this means that you should have experience bootstrapping machine learning operations workflow. And we'll see later what this is exactly. So remember that when you are trying to get a new data scientist or trying to add a new data scientist to your team, or in this case, a machine learning engineer, you have more than one option. You can hire, but one of the best options that you have, and one of the most flexible options, is also use a team augmentation service, like the one provided by Imaginary Cloud. And this is a great solution if you want to ensure quality and flexibility. And this means that much of this experience in product-oriented machine learning and ML ops already come out of the box, and you don't have to look for it when recruiting. So to recap, secret number one is your first team member should be a machine learning engineer with experience in product-oriented machine learning ops. So let's now take a look at what exactly is machine learning ops. So if you're trying to build machine learning features into your product, you need to have some further considerations in mind. So machine learning ops doesn't just look at the modeling and testing part, which is the part where you actually build the algorithms and test them. machine learning ops tries to capture the whole flow from the experimentation, data acquisition, and business understanding up to the deployment, operation, continuous delivery, and also the monitoring of your models while they are in production. And so the objective of using machine learning ops is really to automate as many of these processes as possible. And so we try to make the lives easier for data scientists so that they can produce models faster and iterate over models faster. And the job of a data scientist, as is implied by the name scientist, is really to experiment, try different models. And machine learning ops is the key to being able to experiment more easily. And so if you're outsourcing your data science team from a third party, you should make sure that they are familiar and adopt machine learning ops best practices. So if you look at the ecosystem of machine learning ops, at first it is a bit overwhelming. You have many different parts of the machine learning pipeline, and each of those has different tools that can be used to accomplish it. And so at first it might seem like you have a lot to look at, but there's a good way to start diving into this ecosystem, and that is to start simple. So you already have, let's say, a code repository where you are developing your product. And so if you're building a machine learning feature into your product, you should start simple and start building that machine learning ops flow as needed. And so you should use simple tools that integrate well with your current code repository, and also start automating the different phases of the machine learning pipeline as you need. So you can first start with training and testing, and this makes your experiments easier. And then you can automate your deployment, your monitoring, and finally automate the retraining loop. So this means if your model is starting to perform badly or your performance is drifting, you can detect that automatically and retrain the model and redeploy it. And there are tools in that ecosystem to do that. And so what you really want to do in the end is build a machine learning ops stack. You have these different functional components that you need to create, and you can start choosing technologies for each of them and slowly build these machine learning ops stack. And if you hire a machine learning engineer first, this will be perfect because he will have the expertise to build this pipeline, and we'll see that this will make data scientists work much more efficiently. As an alternative, instead of building these machine learning ops stack by yourself, data scientists are also sometimes accustomed to using all-in-one platforms. And this comes with everything already in the box. The thing is, you need to be careful. If you're planning to use an all-in-one platform, you might get first vendor lock-in. So this means that all of your experiments will be stuck inside a platform and you can't change it. And also this platform might not be as flexible as you want it to be. And so building your own machine learning ops stack might be the most flexible option that you have. And so once you've bootstrapped your machine learning ops flow, experimentation is simpler. And so you have a faster product development in terms of machine learning features. And your team can now be expanded by hiring data scientists. And so data scientists will become more efficient by adopting this machine learning ops flow. So instead of spending time maintaining the features that they are building manually without a machine learning ops process, they'll instead have more time to experiment and build new features, because all of the processes will be already automated. So to recap, secret number 2 is develop a machine learning ops flow and integrate data scientists into that flow so that they become more productive. So let's now say that your data science branch wants to develop multiple data science projects, or you have multiple features that you want to develop using data science. In this case, it's a good idea to set up an internal process because this will help first maintaining a structured approach to tackling new challenges. It will uniformize the steps across the different projects that you have. So if you have data scientists jumping from one project to another, to make transitioning between those projects easier, because it will be much clearer in which phase of the process a project is at the moment. And so it's easier to adapt. And this also makes it easier to identify solutions that may be applicable across projects. So at Imaginary Cloud, we set ourselves apart from the competition by having a very well-refined AI design process. So our process is a technology agnostic process, and it's focused on continuously delivering value to the client. It's also collaborative between the clients and the development team or the data science team, and it's an agile process. So we try as best as we can to closely adapt the process to the business goals of the client. And of course, we have an emphasis on machine learning operations best practices, and this just ensures that the project goes as smoothly and as efficiently as possible. So our AI design process has 4 phases. The research, ideation, and execution phases are sequential, and the technical assessment phase goes or runs in parallel to all of the first 3. So we start the project with the research phase. We have a briefing with the client. We then have a benchmark to identify possible solutions that already exist in the market. So next we have a problem definition phase. And this is where we try to define as clearly as possible what problem we're trying to solve. For example, if you want to build a model to predict something, we define what are going to be the inputs to that model, what are going to be the outputs to that model. And so this just means that we'll have a clear idea of the challenge that we're tackling. And lastly, in the research phase, we identify all the data sources that are available to us. So this just means that during ideation, we already know what data we can use and to what extent. So in parallel to the research, we also start doing the technical assessment. This means that we start doing a high-level architecture of the solution and how this solution is going to integrate with the rest of the product, or if it exists already a product, or what kind of product this solution can be integrated with, for example. And we also have the project plan, and this is where we start defining what are going to be the steps of the project. And we try to, as the project goes on, the project plan becomes more and more refined. And it's usually more refined in the near term and less defined in the long term. And this is what allows us to be agile also. So after the research phase comes the ideation phase, and this is where the fun begins for the data scientists. This is where we do the exploratory analysis, where we try to understand the data that is given to us find patterns in it, find correlations, explore it as best as we can. And so that when we get to the predictive analysis phase, we already know with what kind of data we are dealing with. And in the predictive analysis phase is where we start building models to predict things based on the data that we have. Once we do that, we have something concrete, we start building a proof of concept. And this just means that we take the model and do all the types of pre-processing and post-processing that we need to have something that where the client will look at it and see the value that it adds to its business. And finally, we do a viability assessment. And this just means that based on what we learned from building the proof of concept, we estimate where we can take the things that we build forward. And this means we try to verify if the objective of the clients can be met using this proof of concept, and to what extent they can be met. So what kind of performance we can have, for example, in an algorithm. And yeah. So after the ideation phase comes the execution phase. And this is where we start integrating the solution with an already existing product, if that's the case. And at that point, we also bootstrap our machine learning ops flow. So this allows us to start experimenting. So remember, we only had a proof of concept. Once we do the bootstrapping is where we start trying to improve what we built in the proof of concept. And this is the final production increments phase. This is with the product already integrated, maybe already deployed even, and already being used. We start improving the product by relying on the machine learning ops flow. So to recap, secret number 3 is when developing multiple data science projects, you should develop an internal process or internal processes to standardize all of those projects. So let's now say that you're trying to scale up your data science team. So if you want to do this, you will want to hire not only data scientists, but as we mentioned, machine learning engineers first, but then also data engineers and data analysts. And it's important to know how you can structure the teams to get the best out of them. So let's say you already have a product engineering team with backend developers, DevOps, and front-end developers. What really needs to happen here is that you need to divide your data science team into 3 different sub-teams. One would be the data platform team, and this will be composed by data engineers and machine learning engineers. So the data engineers need to build the required pipelines so that data scientists and data analysts can then do their job easily. So it's the data engineers that take the data that is present in the product databases, and they make sure that this data can be all aggregated and accessed easily by the data scientists and the data analysts. The data scientists in the product data science team then can use this data from the data platform to build and to train their models. And they do this using the machine learning ops flow or pipelines created by the machine learning engineers. The machine learning engineers are also responsible for making sure the models that the data scientists build are optimized for production environment. And so this really means that there's almost like a barrier between the product engineering team and the data science team. So data scientists get their data from the data platform, train their models and pass their models through the data platform again to be checked by the machine learning engineers, and only then are they deployed. The same goes with the business analysis team. So this is usually where you find your data analysts. You can also have data scientists here, but the main purpose of this team is to also use the data platform to get data and then get insights from that data. This means, for example, visualizing that data and plotting it. And the objective of this team is then to produce insights that can be taken to upper management to serve as decision support. And so this can be in the form of data visualization or even forecasting models, for example. And so this team also relies on the data engineers to get their data easily and get their data from multiple departments or multiple parts of your product. So in terms of data management platforms, the paradigm has been shifting a bit. Before, the main way we did this was using data warehouses. This means that we extract the data from the database, from the products databases. We transform it and we load it into new databases where the data is all cleaned up and stored in a format that it's ready to be used by business intelligence and also to produce reports. This has one limitation, which is this can only be done with relational data, so only tables of data. And that's why in around 2011, we started seeing the data lake pop up. And this data lake, besides structured data, it also supports semi-structured data and unstructured data. And so instead of using relational databases to store this data, it uses file systems to do it, usually distributed file systems. And this allows then the data scientists and machine learning engineers to use this data directly from those file systems. And also a data warehouse can be built on top of your data lake to then provide support for your business intelligence applications. This seems like a good solution. The problem with this is that it's lacking some key aspects that are important and that were present in the data warehouse. One of them is ACID transactions. So using this data lake, you might have multiple writers to the data lake, and there's no way to ensure ACID transactions in this case. And also the performance of having a data warehouse on top of a data lake might not be the same as just having one data warehouse. So that's why around 2020, the lakehouse architecture started to appear. And this just means that all of your data, structured, semi-structured, and unstructured, is also stored in a file system, but it is stored in a format that can be used directly for business intelligence application, as well as data science and machine learning applications. So this greatly simplifies the data lake, and having the data in this format allows us, for example, to assure ACID transactions or to support ACID transactions, and also, for example, support time traveling on the data. So seeing the data as it was, for example, 2 years ago. And so you can build time reports or time sensitive reports of your data. And so the main pioneers of this architecture is Databricks. And so that's one of the technologies that's the most widely used today as a data management platform. So to recap on scaling up your data science team, data scientists build the models and data analysts build insights from the data. Data engineers build the infrastructure to easily access and aggregate the data. Machine learning engineers build and maintain the machine learning ops flow and also optimize models for production. And finally, the product engineering team uses the models created by data scientists as part of the product. So to recap, to scale up your team, you should build a data management platform. So let's now look at all the secrets in sequence. First one is your first team member should be a machine learning engineer with experience in product-oriented MLOps. Second one, develop an MLOps flow and integrate data scientists into that flow so they become more productive. Third one, when developing multiple data science projects, you should develop internal processes. And finally, scale up your team by building a data management platform. This is the end of the webinar. We would just like to ask you or to remind you that in Imaginary Cloud, you can book a free data science consultation call. And this means that we will help you assess the main role of your data in the wider business scope and also the potential it can unlock, and also the steps you will need to take to implement a data science plan in your business. Okay, so this is the end of the presentation. I would like to open up the Q&A session.
Thank you, Pedro. Thank you for the presentation, and thank you for sharing the 5 secrets, the 4 secrets for building a data science and integrating data science into the business. I just would like to add to the topic of this conversation that is companies and teams usually have different problems, and the size of those problems are usually directly proportional to the size of the companies. It's very common for a company that starts building a data science team with, like Pedro said in the beginning, with a data science engineer, and then starts to add data scientists to the mix. Not all companies will reach the maturity stage of a big data science team with all those layers that Pedro shown in the last part, because the problems that they are solving might not need that scale. So for example, if you have just 1 or 2 data science problems to solve in your company, it means that you might not even need to create internal processes that are common to all to everyone in the data science team, because they will just be a bunch of people. But it's important for you to at least have some structure on how they are going to approach the problem. What Pedro showed you is how we approach data science from a process perspective. I mean, it's not mandatory that you follow our process. I mean, it's good that you know a little bit more, that you need a process, and if you bring someone in, if it's not someone from our team, but when you bring someone in, that person at least should know or should have a process to address the problems that you have, and should show you, this is how I am going to actually address your problem. So they should listen to you, and they should with you together design a process to actually take you to where your company needs to be from a data science perspective. What we've shown you is a process, is the one that we follow, but it doesn't need to be the process that you follow. Our recommendation is that you actually have, when you have someone in there, that they follow a structured approach and not just do steps and go in a way completely random to try to solve the issues that you have. So this was just what I wanted to complement in there. Regarding to now the questions, and so I see that we are a little bit shy. We only have 2 questions in here, so we are going to address them, and we might have a couple of minutes in the end. So please shoot questions that you might have so that we can address them. So I will start with the first one. There's so Kevin, this is the first time I'm using this webinar too, but that's a button in here that says Start Live Answer. So I'm just going to see what this button does. And the question, so I click the button, and the question is, what makes a great data science team? Please speak from a personal to the technology stack and culture point of view. So Pedro, I believe we already addressed some of those topics, but if you could summarize that, I think it would be good. And thank you, Margarita, for the question.
Okay, so great question. Thank you. I would say from a personal point of view, what makes a great data science team is really that there's support between team members. And so a data scientist shouldn't feel like he's tackling a problem alone and has no one to help him with if he finds any problem. And so what makes a really great data science team is when you're working as a data scientist, and if you find a problem, there's usually someone with more expertise than you in that specific problem. And so there's always someone you can rely on. Without this, many data scientists tend to become frustrated. And this usually happens, for example, if a data scientist is trying to automate some of its processes. If it's a data scientist without a computer engineering background, it's sometimes difficult to do this, especially if there's no machine learning engineer to rely on. Then from the technology stack perspective, I would say the most important thing is to always be up to date with the technology advancements that are happening. For example, the data lakehouse that we mentioned is something that only really appeared 2 years ago. And it's already redefining the way we manage data. And so if you want to have the best data science team in this regard, you should really be paying attention to everything that's happening in the ecosystem. And then lastly, from the culture point of view, I would say the answer is kind of similar to the personal point of view. I think having support from your team members is really a matter of culture. So it's part of the culture of a company if all the data scientists are available to interrupt their own work to help someone else. And if this isn't part of the culture, then you won't have the best data science team that you can.
Thank you, Pedro. Thank you for the answer. Um, right. So then we have another question from Alexandra Mendes. Thank you for having this question, which is, the question is, since more data is produced every day, how can we go through the store? Apologies. Since more data is produced every day, how can we get enough storage space? How to ensure there isn't a data loss, conflicts, or inconsistent data?
So with this,
Pedro, I don't know you can answer. Yeah, I might add a little bit to the end, but go ahead.
sure, I can answer this one. So in terms of the storage space, there's an easy solution for that, which is cloud storage. So cloud service providers basically provide you with almost infinite storage if you're willing to pay for it. And there's actually many ways to optimize and to cut down on costs for storage. If, for example, you have data that you know that you're not going to access for a long time, there are instances of cloud storage that take advantage of this and also cost you less if you compromise with not reading or writing to that space. And then in terms of data loss, conflicts, and inconsistent data, that's really a matter of using best practices when it comes, for example, to ACID transactions to avoid inconsistent data. Also using proper schema management to avoid data conflicts. And in terms of data loss, for example, using distributed file systems with sharding and replication. And so this ensures that all of these things together ensure that you won't find or you won't run into all of these problems.
Thank you, Pedro. Thank you. So we have another one. We are 1 minute. Pedro, if you don't mind, I will answer this one. This is I can answer this one from a project management perspective. So does an agile approach cause more harm than good? I mean, usually projects start on the fly without architecture being fully built, or at least the data flows or processes needed. Should the architecture be a prerequisite of a data science project? Uh, I can let Pedro answer the rest. The only thing that I would like to add to this is about the agile is moving fast. You can do an approach where you think first. The main issue is usually your external environment. If your environment where you are, your competitors are always launching new projects and they're always outrunning you, then you need to act and move fast. And sometimes agile is the best thing for that. If your environment is very, very stable, things don't change, you are number one on the market, and you say the rules, then you can afford to do a more structured and thoughtful approach of think first and act later. But this all depends on how fast the environment is changing around you. So do you need to change fast and adapt to the environment, or do you actually have the luxury to think first and act later? And this is from a broader project management perspective. Pedro, I don't know if you want to add something to this or not.
I would say the last part of the question, should the architecture be a prerequisite of a data science project? It depends. If it's the architecture of the solution that or the product that you are going to integrate with, I would say that's not a prerequisite. So if you're building a data science solution that solves a certain task, it doesn't really matter what the architecture of the product that already exists is. So as long as you deploy your solution and it can be, for example, you deploy it, for example, as a microservice, can be used by any kind of architecture that you decide to use in your product. In terms of the architecture of the solution itself, the data science solution itself, it's important to have an idea on what you're going to build. But even if you decide to change down the line, most of the things, most of the parts on your solution will be common, even if you decide to change architecture. So the training and testing pipelines will be the same. And what will change is usually just the deployment. So let's say, for example, instead of using a microservice, you want to deploy or you want to publish a package with your model to be used by another service. This can easily be done without too much time consumed. So in recap, no, it's not really a prerequisite.
Thank you, Pedro. Thank you also, Tiago, for asking this question. Usually, it's a very common decision that we need to make. Should we go agile or should we think a lot before we actually do the move? It totally depends on how stable or what's the chances of your plane surviving the battlefield or not. Right. So we are over time. I think we can stay here answering questions. I just want to do a final final wrap up of everything, and then we can continue answering questions in here. So my final wrap up is very simple. So you are now aware of what, I mean, in our opinion, what is relevant to do data science. Of course, we are here because we offer this service and we have experience in this. It's not mandatory that you engage with us. I mean, we would love to, but it's not mandatory. What is mandatory is that you put in practice the secrets that we have shared today, because these are really, really relevant. It will save you a lot of time and a lot of trouble. Pedro, I would also like to thank you for doing the presentation and sharing all this knowledge. I hope everyone enjoyed and at least learned something that they could use and take back. We are available to talk to you free of charge if you have any doubts. We want to have you to book a free consultation, bring one data scientist to the team and just to the meeting and just explain from their opinion what they advise you to do, but it's then up to you to engage with us or not. So I think it's a good investment of your time. And I would also like to thank everyone on the scenes. I mean, you're not aware, but there was a couple of staff involved on getting all of this prepared and getting this webinar out of the door. So I would like to thank them all also, Anjali and Guilherme, for putting this together. And I hope everyone enjoyed again. We'll stay here answering questions for those that have. Pedro, please go ahead. And thanks again, everyone. So the next question, thank you. The next question from Janit. Janit, thank you for asking this question. What would you recommend to a person that is interested in becoming a data scientist?
So this really depends on the background that you have. Firstly, if you haven't learned programming yet, I would suggest you to start by learning Python. One alternative is to use R. R is usually more suited for data analysis. You can also do machine learning with it. And there's actually now packages to build or to deploy those solutions, but it's still not as well supported and used as Python. So I think Python is the safest choice to do that right now. And then once you start using Python, I would suggest you to learn the different packages in the Python ecosystem for data scientists. This is, for example, scikit-learn, pandas, matplotlib if you want to start plotting your data. These are really the core packages that you use for data science. If you want to get into neural networks, you can start learning PyTorch or TensorFlow. And if you want to start applying that knowledge, one of the best advice that I can give you is to start doing Kaggle challenges. Those are public challenges. If you go to Kaggle, or if you search Kaggle on Google, you'll see there are multiple competitions. Some of them even have prizes. And these usually revolve around a prediction task. And so it's great if you just go there, pick a challenge, apply some of the algorithms that you've learned, and try to see how you perform on the leaderboards.
Yeah, thank you, Pedro. I will just double down on Python. So you, like Pedro said, you have R and you have Python. R usually came from a more statistical and mathematical oriented world, and you have Python that came from the computer science world. The thing is, Python is actually used in production in a lot of the backends of the products that you see nowadays. So if you are like a scientist using Python and your software engineering team is using Python for the background, you probably won't be using the same packages and the same libraries, but you'd be using the same technology and you'd be using the same programming language. So Python is closely to the data engineering part, but still allows you to do the data science part very, very well. And even machine learning, Pedro, correct me if I'm wrong. I don't know if there's a lot of support for machine learning in R, but at least the packages that you've talked about, PyTorch, etc., they are all Python based. So I think it's also an advantage in there for machine learning. But I don't know, is there a lot of support for machine learning in R or not?
There's a lot of development going on in the recent years, but at the same time, there's a lot of development in Python, and I just feel like R is a bit further behind. I think it's an easier language to get results in. It's easier to plot data, for example, and to build models. But then to integrate those models with other things, it becomes more complicated.
Thank you, Pedro. Thank you. And now I have last question in here from Gary. So thank you, Gary, for this question. It says, if I'm using a freelancer and I'm not technical, how can I understand if they are good? Okay. Pedro, what are your thoughts on this?
That's a tough question. If you have data scientist friend, it could be useful. But if you are not technical at all, I would say look at if he has a GitHub or a GitLab account, look at his profile, the projects that he did, and see how well you can understand what he did. So if he's a good data scientist, he will know how to present the things that he did properly and to a non-technical person. And so this could be a great indicator of the quality of
Yeah,
this freelancer.
yeah. I would also have going back to the thing about the process. Ask them on how they are going to solve your problem, and if they actually can explain the process in a way and in steps that you can understand, that's okay. If not, then there are issues in there. So yeah, you should be at least be able to understand, explained by that person, how are they going to take you to the end goal. Usually there's a lot of experiment in between, and that person should tell you, I'm going to experiment this. If this doesn't work, I'm going to experiment that. If they are too certain or if they don't have a plan, then there might be issues in there. Thank you for this question. Okay, so I believe we're done with all the questions. I'm sure that after we get out and you process all the information that we gave you, you might have some more. So again, feel free to reach us. Otherwise, thank you so much for being here. Thank you so much for the time that you invest in that. I really hope that you learned something from us today. Pedro, again, thank you for allowing us to pick your brain on the data science topic and the secrets that we have about how to create a great data science team. And yeah, I hope we enjoyed. I hope to see you on the next webinar. Thank you. Thank you so much. Cheers. Bye.
Thank you all. Bye.